Hello students, welcome back to Embedded System course. So in previous lecture uh, we studied mode 1 of timers of 8051 microcontroller and how to program in mode 1 to generate time delay, what are the steps involving. Also for a particular or desired time delay, how to determine initial value to be loaded into timer registers of either timer 0 or timer 1. So that we studied. Okay, so after that one more point we studied, that is significance of a gate bit. Okay, from T mode of timer 0 and timer 1, what is its significance. So these points we studied in a previous lecture, that is lecture number 2 of part number 1 of this chapter number 2, that is 8051 timers and serial port programming in C. Okay, so right now we are in lecture number 3. Okay, so of part number 1, that is programming 8051 timers. Okay, and in this lecture we are going to study programs to generate time delay uh, by using timers 0 and 1 of 8051 in mode 1. Okay, that is mode 1 means 16-bit mode. Okay, so first program, that is we are using timer 0 in mode 1. So I will read statement here: write an 8051 C program to toggle all the bits of port 1 continuously with some delay in between. Use timer 0 16-bit mode to generate the delay. Okay, so what we have to do? We have to toggle uh, pins of port 1. Toggle pins of port 1. Okay, so here I will use pen. Okay, so to illustrate this problem I can draw a diagram here. So okay, no, it's not working somehow. Okay, so suppose, sorry, suppose this is 8051. Okay, and these are port 1 pins. Okay, so here what I want to do, I want to output, or I want to toggle data on this pin. Means suppose 0, if I output 0 1 0 and so on, and last will be 0, that is the first. I have to output 0 1 0 1 0 1 0 1. Okay, so alternate bits are here 0 1. Okay, so after that first I have to output this data, that in hex it is actually 55H. Okay, and then I have to generate some time delay by using timer 0 in mode 1. Okay, and after that I have to toggle these pins. Means I have to, if it is 0 I will make, I have to make it 1. If it is 1 I have to make it 0, and so on. 0. Okay, so that will 1 0 1 0 1 0 1 0. It is in hex, it is AAH, and after that again I have to call some time delay by using timer 0 in mode 1, and I have to repeat this. Means again I have to go to this step, again I have to output 55 to port 1, and this should happen continuously. Okay, so that is the problem. So see here in the program, so program is written. So in this program there are two functions. So this is one main function. Okay, and this is another function. Okay, so this function is used here to generate time delay by using timer 0. So the name of this function is t0 delay. Name given is t0 delay, means to generate this delay uh, timer 0 is used, and this is by default main function. uh, so hash include reg51.h void t0 delay, uh, void. So this is function declaration of t0 delay function, because we are referring it before its definition. So this is definition of function, and it is, we are referring from main function from here. See here, t0 delay, t0 delay. Okay, and its definition is coming afterwards. So it is necessary to declare this function in the start of your program. Okay, so see in void main void function, while one means it is infinite loop. So whatever statements in this loop, that is in between this opening and closing braces, that will be repeatedly executed infinite. Okay, so that is the meaning of infinite loop. So first p1 is equal to 0x55. So 55, 0x55 is assigned to P1, that is port 1 of 8051. Okay, so that means we are outputting 55 to port 1 pins. So here first 55 is being outputted. Okay, after that T0 delay, we are calling this T0 delay function. Okay, so after this, control will get passed to this T0 delay function. Okay, so because we are calling this function here, so control will go here and it will execute this function, and after execution of last instruction, again control come back, okay, from here, and it will go to the next instruction below this t0 delay function. Okay, so now see what happens in this t0 delay. So t mod is equal to 0x01. So this 01 value, hex value, we are loading in t mod, timer mode register. Okay, so from this timer mode, upper 4 bits are used to configure timer 1, and lower 4 bits are used to configure timer 0. So in lower bits I am loading 1 value, hex 1, and in upper bits 4 bits I am loading 0. Means here I am configuring actually timer 0, in mode 1. If I load 01 into t mod, I am configuring timer 0 in mode 1. So that is been asked. I have to use timer 0 in mode 1. Okay, so this will configure timer 0 in mode 1. Then TL0 0x00 means I am loading count in TL. So TL0 and TH0. So this timer register of timer 0 will be used. In TL0 I am loading 00, and in TH0 I am loading 35. Okay, so here by using these two instructions I am loading initial count in TL0 and TH0, and that is 3500. After that TR0 is equal to 1. So TR0 bit is there. Okay, TR0 bit is there in TCON. Okay, timer control register, which is used to control the operation of timer 0 and timer 1, and TR0 bit is for timer 0, to turn it on or off, to start it or stop it. Okay, so this TR0 bit is defined in this reg51.h. Okay, so that I can directly use this symbol here. So TR0 is equal to 1 means I am turning on timer 0. Okay, so when timer 0 starts, okay, because we have made tr0 bit 1, means it will start timer. Okay, means pulses will start reaching to this timer registers. Okay, and count in this timer register will start incrementing, okay, by 1 due to single pulse. Okay, so count in th0 and tl0 starts incrementing. It will starts incrementing from 3500, and it will reach when, after that, see, after turning on timer, what we have to do, while tf is equal to 0, means this is a relational operator, equal to relational operator, it is comparing value in tf0, that is timer flag of timer 0 in a tcon with 0. Okay, so while tf is equal to 0 and semicolon, means what, your program will be in this loop checking tf0 flag bit until it becomes 1. When it becomes 1, it will come out of this loop and it will go to next statement, that is tr0 is equal to 0. Okay, means we are waiting for tf0 to become 1, and when tf0 becomes 1, when count in this ts0 and tl0 reaches maximum, okay, that is f, and after that, due to one more pulse, it rollovers from all ones to all zeros, means it will become 0000h, count in th0 and tl0, rollovers from all ones to all zeros. All ones means this is 16 bit, bro. So f means 11111, so all 16 bits are 1, means count is rollovering from all ones to all zeros. When this happens, this tf flag bit becomes 1, tf0 will become 1, and it will come out of loop and go to the next statement. Okay, so tr0 equal to 0 means we are stopping, so we are stopping timer 0. Okay, timer 0 will be stopped, and again this tf0 is equal to 0 statement will make this tf0, okay, which was set, now it will reset. Okay, and due to this closing brace, again control come back to the main program, to the statement below this t0 delay function call. Now p1 is equal to 0xaa. So now we are outputting, or we are toggling now port 1 pins, because in previously we outputted 0101 0101, and now we will output 0101 1010. Okay, and after outputting this, means toggling of port 1 pins, again I am calling same delay, again control will come here, okay, in this function, and it will generate a particular time delay. So that time delay that will get generated, okay, its value, actually it is not asked in the statement of a particular time delay, so we are randomly generating a time delay in between toggling of port 1 and port 1 pins. Okay, same time delay we are calling here, and it will generate certain time delay, and that amount of time delay depends on what initial value you have loaded into TL0 and TH0. That delay being offered by this timer 0, we can calculate by using this formula, that is f minus 3500h. Okay, so that will so that decimal formula we are using, okay, ca. So that formula is actually like this: 65535, okay, minus n plus 1, okay, and multiply by f oscillator divided by 2. Okay, so if oscillator is 11.0592 megahertz, then this value will be 1.085 microsecond. So n is actually decimal equivalent of 3500, which is if we place here and if we derive this formula, that value becomes 51968, that is 65535 minus n, which is decimal equivalent of 3500, plus 1, this value will become 51968. It will get multiplied by this 1.085, and I will get how much time delay? 56.384 millisecond. Okay, so this delay function will generate time delay of 56.384 millisecond. Okay, so after each 56.384 millisecond, port pins of port 1 will get toggled. Okay, so this is the program. Okay, so now we will move to next program. So next program, write an 8051C program to toggle only bit P1.5 continuously every 50 millisecond. Okay, use timer 0 mode 1, that is 16-bit mode, to create the delay. Test the program on the these two microcontrollers. So what is asked here? So here so this is your microcontroller. This is 8051. So this is pin number sorry, this is not the program, this is the program. Okay, so this is the program. So here this is 8051. Okay, and here this is P1.5, that is pin number 5 of port 1. Okay, and I have to make this pin toggle. Okay, means first I have to output 0, then what should happen? 50 millisecond delay means output on this pin will remain for, that is 0, it will remain 0 for 50 millisecond. Then I have to toggle this, means I have to make it 1, then again I have to call 50 millisecond delay. Okay, 50 millisecond delay. Okay, so this is 1, I have made it 1, so let me erase it. Okay, so after making 0, 50 millisecond delay, I have to make it 1, and after that I have to put here 50 millisecond delay. Okay, and after that again I have to make it 0. Okay, then 50 millisecond delay, so this will be loop. Okay, and this should happen continuously. Okay, because it is asked here continuously every after every 50 millisecond, pin number 5 of port 1 should be toggle. Okay, and for that I have to use timer 0 mode 1 to create the delay, this 50 millisecond delay, and test this program on 8089C51 DS89C 420. So here basic assumption is here, since this is a instruction cycle is 1.085 microsecond, or this period of timer clock frequency is 1085 microsecond, that is of frequency f oscillator divided by 12. So here f oscillator is assumed 11.0592 megahertz. Then only this period of f oscillator divided by 12 will become uh, it will become uh, 1.085 microsecond. Okay, so so here this is the program. Let us see. So include reg51.h void t0m1 delay. Okay, this is the function declaration. Okay, of function which is generating time delay of this 50 millisecond. Okay, and name of this function is t0m1, that is timer 0 mode 1 delay. Okay, and that is written after main function. So this is main function, and this is t0m1 delay function. So again one variable I am declaring, that is of type s bit, that is single bit from SFR. My bit name is my bit is equivalent to P1 caret 5. Okay, means I am representing pin number 5 of port 1 by using symbol my bit. That is the meaning. Means in program onward I can use my bit keyword instead of this P1 dot 5 or caret 5 that represents address of pin number 5 of port 1. So void main void, while 1 means continuously infinite loop. These two statements in the loop, that is between this opening and closing braces, will be executed. So my bit is equal to tilt my bit. Okay, so this is bitwise not operator. Okay, so if my bit is 0, okay, so tilt 0 means it will become 1, and that will get assigned. Means whatever previous status of my bit, that is port 1 pin number 5, if it is 0 it will become 1, and if it is 1 it will become 1. Just inversion of data in pin number 5 of port 1, inversion of pin data of port 1 pin number 5, and then I am calling this delay. Okay, t0m1 delay. After that it will come here. Okay, it will execute this function. So what is written in function? So t mod is equal to 0x01, so this will configure timer 0 in mode 1. TL0 is equal to 0x fd, TH0 is equal to 0x 4b, means TL, TH0 and TL0 are loaded with initial values, that is a 4b FD. Okay, and this is calculated by using formula, this formula. Okay, so in hex this formula is 65535. Okay, minus n plus 1, okay, into 11.085 microsecond. If we reverse this formula, this is time delay generated. If we load this value n, its hex equivalent into TL0 and TH0. Okay, if we reverse this formula, means first I have to in first step I have to divide this time delay by 1.085 microsecond. Okay, then whatever value comes, okay, so if that is in decimal n, then I have to subtract that value from 65536. Okay, so in third step I will get this value, some value in decimal and in fourth step I have to convert this value in hex. Okay, so if I perform this calculation, means first I have to divide what delay I want 50 millisecond delay. Okay, so that 50 millisecond, first should be divided by 1.085 microsecond, whatever value get, suppose it's decimal equivalent n, then subtract that. Okay, so this is first step, this is second, subtract that value from this 65536, I will get value n, then okay, then convert this value in hex, that is YYXX, then load XX in TL0 and load Y in TL0. Okay, in this way I am getting 4BFD. So see here, after this operation 65536 minus n, where n is the value I am getting in first step, so I am getting this value n, that is a 4. Okay, so this is the reverse. So if we put 4BFD in TL0 and TH0, what amount of delay this will generate? So that is calculated here by using this formula. Okay, so I have to convert this 4BFD into decimal equivalent. That is we assumed n. So that value is uh, 46083. So this value, if you calculate, so it will become 46083, and if multiply by 1.085, that I will get 50 millisecond, means this function is generating 50 millisecond delay. Okay, so after loading values in TL0 TH0, that is FD4B, to generate 50 millisecond uh, delay. Okay, after calculation we have got these values, so we have to load these values in TL0 TH0. Then TR0 is equal to 1, means we are turning on timer 0. Okay, means after that what will happen, this count in TL0 and TH0 will starts incrementing by 1 after each time clock frequency pulse. Okay, so so this count will start incrementing, and after that we will be in loop, continuously in loop, checking TF0 flag bit. Initially it is 0. Okay, and when it will set, when count in TL0 and TH0 rollovers from all ones, that is it becomes F, and due to one more pulse it will rollovers from all ones to all zeros. When this thing happen, this TF0 flag bit will become 1, and control will come out of this loop and go to the statement below. So next statement is TR0 is equal to 0, means turn off the timer 0, and TF0 is equal to 0, means again make this TF0 bit 0 for next cycle to generate time delay by this function. And after that control will come back to the main program here. Okay, again from here it will go to again next pass, because these statements in the loop continuously executing. After execution of this time delay, what will happen, control will go again to first statement to execute it. Okay, now my bit is equal to inversion of my bit, so previously it was 0. Okay, and after that 50 millisecond delay is there, now it becomes 1. Again this delay function is called, again it will generate 50 millisecond delay, and it will um, continue. Okay, so on pin number 5 of port 1, actually what is happening, so output will remain 1 for 50 millisecond, again it will remain 0 for 50 millisecond, again it will remain 1 for 50 millisecond, again it will remain for low for 50, and this will continuous. So this is of 50 millisecond and this is of 50 millisecond. So time period of this square wave actually get generating here, it is 100 millisecond. If time period is 100 millisecond, we can calculate its frequency. F will be equal to 1 upon 100 millisecond. So that you can calculate and you will get value sum in hex. Okay, x value in hex. Okay, in this way this program generates a precise time delay of 50 millisecond while toggling pin number 5 of port 1. In this way it is generating square wave, it is generating square wave of a particular frequency whose time period is 100 millisecond. Okay, so this is timer 0 mode 1 programming. So next is timer 1 programming. So that is very much similar to the timer 0 programming. So sorry. Okay, so now we will study this. So timer 1 mode 1 programming, this is program number 3. Write an 8051C program to toggle all bits of port 2 continuously every 500 millisecond. Use timer 1 mode 1. So it is tested for DS89C420 and crystal frequency is 11.0592 megahertz. So same frequency as used in previous examples. So hash include reg51.h, white T1M1 delay. So I'm declaring a function here. Okay, having name T1M1 means timer 1 mode 1 delay, means I'm using timer 1 in mode 1 to generate a delay of 500 millisecond. Okay, and what we are going to do, we are going to toggle all the pins of port 2 continuously, and in between we should have delay of 500 millisecond. Okay, so that is the problem. Void main void unsigned char x, I'm declaring x as unsigned char type of variable. P2 is equal to 0x55 means first I'm making bits of port 2 bits. I'm making 0 1 0 1 0 1 0 1. Okay, then while 1, okay, means infinite loop. So whatever statements in the loop, that is these two statements, p2 is equal to tilt p2 and for statement, these two statements will be executed continuously infinitely. So what will happen first time, p2 is equal to tilt means inversion operator on p2, means we are complementing port 2 data. So previously it is 0 1 0 1 0 1 0. Now due to this instruction, what will be the data on port 2 pins, it will become now P2 is equal to 1 0 1 0 1 0 1 0, because this tilt is bitwise inversion operator. Okay, then for x is equal to 0, x is less than 20, x plus plus, we are actually, by using this statement, we are repeating this loop for how many times, 20 times, because x is equal to x is less than 20. This is the condition for continuation of loop. So this for loop will, so what are statements in the loop, that is a function called to T1M1 delay. So this function is being called for how many times, 20 times. Okay, because we have to generate a large delay, that is 500 millisecond. Okay, so to generate that delay, what I have done here, I have written this T1M1 delay to generate time delay of 500 millisecond divided by 20, that is I think 25 millisecond. Okay, and this T1M1 delay, I have written this function to generate 25 millisecond delay, and I'm calling this function 20 number of times, means multiply by 20, and that will generate delay of 500 millisecond, because this large delay I cannot generate. Okay, by using single function called to this function. Okay, so see what will happen. So first I have outputted AA to port 1. Okay, then I am calling this for loop. So this for loop will call this T1M1 delay function 20 times. So what will happen, see in this T1M1 delay, so T mod is equal to 0x10. So this will configure timer 1 in mode 1, because I am using timer 1 now. Okay, so I'm using timer 1, so I'm configuring timer 1 in mode 1. Then TL1 is equal to 0x FE and TH1 is equal to 0x A5. So I have loaded TH1 and TL1 with values, that is A5 and FE. Okay, so this I have values derived. Okay, for 25 millisecond delay. Okay, so there are steps. For example, first I have to divide this 25 millisecond by 1.085 microsecond. Whatever value I get, I have to subtract that from 65536. Whatever value I will get, if I convert it to hex, I will get this A5FE. Okay, and this again, if I put this value in the formula, okay, like 65536 minus 42494, where 42494 is equivalent of A5FE, so 2305, and if I put that value in formula 2305 multiplied by 1.085 microsecond, it will become 25 millisecond. Okay, so that is the formula for time delay generated by uh, timer, that is equal to 65535 minus n plus 1 multiply by 1.085 microsecond. So 1.085 microsecond because we have used here 11.0592 megahertz clock frequency. Okay, so same here in this calculation we have done. So I will get this time delay 25 millisecond. Okay, so I have to call this function 20 number of times, because if I multiply this 20 millisecond by 20, I will get 500 millisecond. Okay, so that is the desired delay I want. Okay, after toggling port 1 pins, I have to port 2 pins, sorry, so I should say port 2 pins. So I have to call this 500 millisecond delay. So these values I am loading in TL1 and TH1 will help generating delay of 25 millisecond if I call this function once. Then I'm turning on timer 1 by making TR1 bit 1. Then while TF1 is equal to 0, means operand TF1 bit, okay, 0 आहे तोपर्यंत काय, this will remain in loop. It will continuously check TF1 bit. When it becomes 1, it will come out of loop. When it will become 1, when counting TL1 and TH1 rollers from all ones, that is F to 0 0 0 0 0. When it happens, TF1 bit will become 1 and it will come out of loop, and it will go to next statement. TR1 is equal to 0, it will turn off timer 1, and TF1 is equal to 0, again it resets TF1 flag bit for next operation of this time delay. In this way, here this for loop calls this function T1 M1 delay 20 times, in this way generating 500 millisecond delay. And again after that, again control go to first statement, P2 is equal to tilt P2, it will invert again. Now port 2 bits will become 55H, and again this for loop will generate 500 millisecond delay, and it will continuously happen. Means port 2 pins are toggling after each 500 millisecond of delay being generated by timer 1 in mode 1. Okay, so last program number 4. So see the statement. A switch is connected to pin number 2 of port 1. Okay, so I will draw here. Okay, so in this way switch is connected to port 1 pin number 2. Okay, so this is a switch, this is plus VCC. When this switch is open, data will be 0. If this switch is cold, data will be when this switch is open, data on this pin will be 1. When this switch is closed, data will be 0. Okay, so in this way switch is connected to pin number 2 of port 1. Write an 8051C program to monitor switch and create the following frequencies on port 1, pin number 7 of port 1. So this is pin number 7 of port 7. So what I have to do, if switch is equal to 0, okay, frequency of square wave that is being generated. So task is to generate square wave on this pin number 7 of port 1, and its frequency, if switch is 0, its frequency should be 500 hertz. Okay, and if switch is 1, its frequency should be 750 hertz. Okay, so that means we have to generate two types of square waves on pin number 7 of port 1, depending on what is position of this switch. If this switch is closed, okay, if this switch is closed, means this pin is connected to ground. Okay, means here data is 0, means when switch is 0, this square wave frequency should be of 500 hertz. Okay, so if frequency is equal to 500 hertz, okay, its time period is equal to 1 divided by 500. Okay, so that will be 2 millisecond. Okay, that will be 2 millisecond. And if so, this will be when switch is equal to 0. When switch is 1, f is equal to 750 hertz, means time period will be 1 upon 750, and depending on whatever millisecond time delay. Okay, so for example, suppose switch is 0, that means we want time period of this square wave, that is this time period should be equal to 2 millisecond. Okay, and this should be 1 millisecond, isn't it? And this should be 1 millisecond. Okay, so that means to generate frequency of 500 hertz at this pin, okay, I should design time delay for 1 millisecond, isn't it? So I will toggle this pin, and in between I will call delay of 1 millisecond. It will generate this square wave having time delay of 2 millisecond. In this way, frequency will be 500 hertz. Okay, so I have to determine, okay, value to be loaded in timer 1 register, because I am going to use timer 1. Okay, so TL1 and TH1 value to be loaded into this TL1 and TH1 for delay of 1 millisecond. I have to calculate. I have to divide this by 1.085 microsecond, assuming crystal frequency used is 11.0592 megahertz, and then that should be subtracted from that should be converted to decimal, and it should be subtracted from 65536, and whatever value I will get if I convert into hex. Okay, so I will get value. Okay, so this is FC or 67 FC. Okay, I will get here 67 FC. I have to load FC into TH1 and 67 into TL1. Okay, and if so, this is case when switch is equal to 0. So this will generate 500 hertz square wave at pin number 7 of port 1. If switch is 1, then time delay required is different. For that I have to determine value to be loaded in TL1 and TH1, and that will be 9A FD. Okay, FD 9A. So that value is FD 9A. Okay, so this will generate frequency of 750 hertz on pin number 7 of port 1. Now see the program. Include reg51.h s bit my bit equal to p1 caret 5. Okay, so I'm declaring this p1. So here it should be p1 caret 2. Okay, so I'm using this p1.2. Okay, so I'm just representing pin number 2 of port 1 by using symbol my bit. Similarly, I am representing SW. I'm declaring SW of S bit type of variable, means I'm representing pin number 7 of port 1 by using symbol SW. Okay, then I'm declaring function T0M1 delay. Okay, that definition is coming onward, so I'm declaring this function. Here should be actually T1M1 because I'm using timer 1, but okay, no problem. Void main function SW is equal to 1. First I'm making this SW1. I'm configuring this pin as input by making, okay, SW is equal to 1. Then while 1 means continuously what I am doing this. Okay, my bit is equal to that is tilt means inversion of this bit. My bit means my bit is P1. So here there is a problem, it is not matching. Okay, so here should be, here should be, so switch is connected to P1.2 and we are generating square wave on P1.7. Okay, so here caret. So SW is P1 caret 2 and my bit is P1 caret 7. Okay, so this is a P1.2 and this is P1.7. Now my bit is inversion of my bit. My bit is what? My bit is P1 dot 7. P1.7 means whatever data on this pin I'm inverting. If previously it is 0, I'm making it 1. Okay, this. Okay, so then if switch is equal to 0, so this is a relational operator. If switch is 0 means if switch is connected to, if this switch is on means I have to call T0 M1 delay and passing value 0. So here in the declaration of this T1 T0 M1 delay, in a parenthesis I have written unsigned char, means I am passing unsigned char type of value to this function. Okay, so if switch is equal to 0, I am calling this T0 M1 delay and passing value 0 to this function. Else means this switch is not 0, means this switch is open and it is connected to VCC, means it is inputting 1. Then I am calling this function with value 1 passing to it. Okay, now see, when this function is called, okay, so same function is called, only difference is the value we are passing. If switch is 0, I am passing 0. If switch is 1, I am passing 1. Okay, now control will come here. See, control will come here. So T mod is equal to 0x01. I'm configuring timer. So here it should be 0x10 because I'm using timer 1. So this will configure timer 1 in mode 1. Okay, now if so what will happen when this function is called, value being passed to this function will get assigned to variable C. Okay, C will be either 0 or 1. If switch is 0, C will be 0. If switch is 1, C will be 1. Now if C is equal to 0 means switch is equal to 0, I have to load 67 in TL0 and FC into TS0. Okay, now see here, when switch is equal to 0, I have to load 67 FC into TL1 and TH1 to generate delay of 1 millisecond, so that frequency of this square wave will be 500 hertz. Okay, so that I'm doing, I'm loading 67H into TL0 and FC into TH0. If we calculate how much delay it will get generated, okay, so that is here. Okay, so it will generate this 999 point something. Okay, microsecond, means it is equivalent to, sorry, so this is equivalent to 1 millisecond. Okay, so 1 millisecond means this will be 1 millisecond and this will be 1 millisecond. So total time period of this waveform square wave, so that will be 2 millisecond, and from that if I calculate frequency, f is equal to 1 upon 2 millisecond, that is equal to 500 hertz. Okay, means if value of C is equal to 0 means switch is 0, I am loading this count in TL0. Else means if switch is not 0, I am loading some different value, that is a 9A FD, so that it will generate frequency of 750 hertz. Okay, then if C is equal to 0, these values will be loaded in TL. So here will be TL1 and TH1. Here also TL1 and TH1. Here also TR. So 1 1, because I'm using timer 1. Okay, so T0 should be replaced by 1 here in all these statements. So TR1 is equal to 1 means I'm turning on timer 1. and while TF is not equal to is equal to 0, means we will be in loop until there is a rollover of count in TL1 and TH1. Okay, when there is a rollover, it will come out of loop, means when rollover happens, TF1 bit will get set and it will come out of loop. We have to just turn off the timer 1 by making TR1 is equal to 0. I will reset this TF1 bit to again 0, and due to this, control come back to the main program here. Okay, so here or here, depending on switch is 0, then this function is called with passing value 0, and if switch is 1, this function will be called with value 1. After this, again after this, again these statements will be repeated. Okay, so here in the loop we are first checking what is the switch position. If it is 0, I am passing value 0 to T0M1. It will generate square wave on P1.7. okay, that is my bit represent P1.7. it will generate square wave of 500 hertz frequency. If switch position is 1, okay, then I am calling this same delay with value passing to it 1, and that will generate square wave on P1.7 on P1.7 pin of 750 hertz. So how it is generating two different frequencies. If switch position is 0, we are loading these values in timer 1 registers TL1 and TH1, and if switch position is 1, we are loading different values, okay, in timer 1 register. If we load these values in timer 1 register, it is generating particular time delay that will result in 500 hertz frequency. Okay, and if we load these values in timer 1 register, it will result in particular time delay that will generate frequency of 750 hertz. Okay, so only this statement is different as compared to previous program. Here we are deciding which count to be loaded into timer 1 register depending on switch position, whether it is 0 or 1. Okay, so in this way this program works. So we studied 4 programs, 2 programs on timer 0 in mode 1 and 2 programs on timer 1 in mode 1. So this is first program, timer 0 mode 1. So random delay we are generating while toggling port 1 pins. In this we are toggling a particular pin number 5 of port 1, and then in between we are calling 50 millisecond delay. So this is timer 1 mode 1 program number 3, in which we are toggling port 2 pins continuously, and in between we are calling 500 millisecond delay being generated by timer 1. So here we are calling this function 20 number of times, because this function is written to generate 25 millisecond. 25 millisecond multiplied by 20 means 500 millisecond. So in this way we are generating 500 millisecond delay, that is bigger delay. For that we have to use for loop. Okay, and in last program number 4, we are checking a switch connected to 8051 at pin number 2 of port 1. If it is 0, we are generating the square wave of 500 hertz frequency on pin number 7 of port 1, and if it is 1, if it is inputting 1, means this switch is open, then I am generating a square wave of 750 hertz at pin number 7 of port 1. So this I am doing just by checking switch position and loading different initial values in timer 1 registers. Okay, if switch is 0, I am loading 67 FC in TL1 and TH1, and if switch position is 1, I am loading 9A and FD into TL1 and TH1. Okay, so in this way I am generating 2 frequency square wave at pin number 7 of port 1, depending on what is switch position that is connected to pin number 2 of port 1. Okay, so I think this is sufficient. If any doubts, we can discuss in our live session. Okay, so I will stop here. Thank you.